As we continue in 10.1, our next vocabulary is perpendicular lines. When two lines meet in a plane, they form four angles. But when all four angles are 90 degrees, these are perpendicular. So these lines, this line and this line, are perpendicular, this line and this line. We also have parallel lines. These are two lines that will never intersect, even far off the page. So parallel lines are often indicated with these little arrows, and then because these two will eventually meet, these are not parallel. The next vocabulary, and I warned you this is a vocabulary heavy section, are supplementary and complementary angles. When we can add the measures of angles that are next to each other but do not overlap. Supplementary angles add to 180 and complementary angles add up to 90. So which of the following angles are supplementary and which of the following angles are complementary? So supplementary add up to 180. And if you remember that straight line, straight angles are 180. So over here I can see that the angles next to each other, E and F, are supplementary because the two of these will add up to 180. And A and B are going to add up to 90 because those are going to be complementary because of that. And then if these two are on the other side of that, C and D are also complementary. All right, go ahead and give these a try. This is a little bit different. Determine the missing angles and then explain your thinking. Press play when you're ready to see the solution. And because that line is going to be supplementary, so they add up to 180, and the right angle is going to add up to 90. So angle relationships formed by lines. Whenever there are a collection of lines in a plane, angles are produced where the lines meet. So we're going to look at several different ways that you can cut up lines and look at their angles. So first, we've got to clarify some language here around postulates, theorems, and proofs. A postulate, or an axiom, is a statement that is foundational and assumed true. A theorem has been proven to be true, and the way that we proved it was by using a logical line of reasoning called a proof. So first, let's start here. Vertical or opposite angles. So those are two vocabulary words that mean the same thing. When two lines meet in a plane, they form four angles, and the angles that are opposite each other, like A and C and B and D, are opposite or vertical angles. And these angles are congruent to each other, or angle measures are equal to each other. So let's look here. Identify all the vertical angles. So here, I don't want to overthink this. So let me just grab okay, I don't want to look at all, there's more than two lines meeting here, right? So I just kind of want to don't think about that. Let's just look at these lines here for a moment. Here we go. So here are two lines that have met, line L and line N. And when those two lines met, they made these four angles, and A and C are vertical, and B and D are vertical. And now we can also look at this side over here, and we can see, okay, when M and N met, line M and N, E and G are vertical, and H and F are vertical, because those are opposite those sides there. So suppose that two lines meet in a plane at a point. Use the fact that the angle formed by a straight line is 180 degrees to explain why A equals C and B equals D. In other words, prove that the opposite angles are equal. All right, so let's look at this. We're going to do a proof. All right, so what do we know? Well, they're telling me to use the fact that a straight line is 180. So let's start here. Well, this is a straight line. So I know that angle A plus angle B equals 180. I know that. And I can rewrite this in terms of A. You know, and sometimes in proofs, we just kind of move things around. I subtract B from both sides. Okay, what else do I know? Well, I also know that B and C are on a straight line. So I know that B plus C equals 180 degrees. And I can rewrite that in terms of C. So C equals 180 degrees minus B. So what I notice here is that both A and C equal 180 degrees minus B. So they equal the same thing. So A must equal C. And so I have proved why A equals C, and by the same thinking, we can prove that B equals D. And here it is written out for you. And go ahead and give this one a try. Press play when you're ready to see the solution. And there we go. So now we'll continue on talking about corresponding angles. So if there are two lines in a plane and a third line crosses those two lines, so okay, we've got these two lines, N and M, they're just living in a plane, and then L comes across and it crosses those lines. This is called a transversal. And what happens is it produces four pairs of corresponding angles. So we can see here that this angle is corresponding to this angle. And this angle corresponds to this angle. It's kind of like you can think of it as in the upper left-hand corner, or the north, like the northwest corner for corresponding angles. So identify all the corresponding angles. So when I look here, okay, if I start here, what else is in this section here? I kind of have this, I'm kind of comparing these two sections. So what else is in this corner? So angle A corresponds to angle E. And angle B corresponds to angle F. And angle D corresponds to angle H, and angle C corresponds to angle G. So we can kind of see how they relate. Now something cool happens. This is called the parallel postulate. So when that transversal cuts two parallel lines, so remember before, these two lines were not parallel. See that? They're going to meet eventually. But if it cuts two parallel lines, not only are those angles corresponding, but now they're also equal. So we can say that this is equal to that, and so on. So when we cut parallel lines, corresponding angles become equal. So let's look at this example. Identify all the congruent angles. Remember, equal angles. So these are parallel. M and L are parallel. So if we were to look at our corresponding angles would be equal. So angle A, and this is the symbol for congruent. It's got like a little extra squiggle on top. Angle A is congruent to angle E because they correspond. They're both in the same corner. And then angle H is congruent to angle D. Angle G is congruent to angle C. And angle B is congruent, and I'm sorry that I've mixed up the order here. The B is congruent to angle F. So now the converse is true. That's when we take the opposite, when we say it backwards. So the converse of the parallel postulate states that if the two lines are crossed by a line so that the two corresponding angles are equal, then we can say that the lines are parallel. So reverse. Before, the parallel postulate says you start with two parallel lines, you get corresponding equal angles. But this is saying if you have corresponding equal angles, then you get parallel lines. So it's saying the same thing, but in a different order. Alternate interior angles are the following. So if we've got our transversal cutting our parallel lines. Okay, so now we're going to look at this, and we're going to think of this out here as the exterior. And we're going to think of this in here as the interior. And again, we're talking about it in terms of these parallel lines. So alternate interior angles, what do we have here for alternate interior angles? So alternate interior angles are B and D prime. So B and D prime. Alternate meaning they're on the opposite side of the transversal, and interior meaning that they're inside of these two lines. So B and D prime, and then C prime and A are alternate interior angles. Identify all the alternate interior angles. So again, when we're talking about alternate interior, we're going to be looking at the interior of our parallel lines. So we're only looking at these four angles. And alternate means opposite sides of that transversal. So we're talking about angle E and angle C and angle D and angle F. and we'll continue on in the next video.